Hi everybody, welcome to my class of image processing. This is Professor Chang of Pugyong National University. Today I will introduce about the practice of character recognition. We are doing the practice with the MNIST dataset. MNIST dataset is the handwritten characters, especially Arabic numbers from 0 to 9, and there are so many characters. 160,000 characters images are included in the dataset. Okay, then so this is the page of Core where you can make your own Python codes. If you want to get into this page, you may go to Google and search Core, and you can find easily the link with the first. Then you see this page, and here what you want to do is making a new notebook. So you may click here, and then you will see the blank pages are open, and this is your new Python code in Core. So here you can do something what you want to do. For example, you can calculate 3 multiply 5, and then you can get the result. Yeah, it takes time because it was not connected to the server, but now it's connected. So if you want to run your Python code, then you may type your code here, then you can click this button. Okay, this is the button to run. Or you may press the button, press the keyboard, like Shift and Enter together, and then you get the result. So this is how you use the Core app. And for me, I have already typed all the codes to show you. So I will copy and paste what we have to do. But in your case, you have to type all the things, so it would take some time. Okay, so here, okay, I will get some code here. Okay, then I will run the code. So this is the code how to import the pandas and NumPy, which we are going to use it. And then we can open the MNIST data. MNIST data is already in your server as the sample. MNIST train small and MNIST test. Here it says that MNIST train small because it does not have all the MNIST data. MNIST data itself is pretty big, so here is just a sample data uploaded. Okay, using this code you can read the data, and the second line here is converting the pandas data into NumPy data. If you are not familiar with pandas or NumPy, it is better for you to run it's better for you to learn the pandas and NumPy first before watching this video. Okay, then if you run the codes, then it has been done. Nothing is displayed, but if you just type data and run, then you see all the data are inside. You see the first line of this data are the 6, 5, 7 something. This is the target of the data. And the second line, from the second line to the end, it is the image pixels. So for example, so first, this is the first data, and the first thing here is the first pixel, it's not pixel, first value here is 6, so which means that this data is 6. This denotes is the image of number 6, and the other things, other values are or the pixel values, and we can plot this data. Okay, let's try to plot it. To plot the data, we need to import matplotlib the pyplot as plt. So here, okay, then we can use the pyplot and plt plot. Okay, let's try to plot data. Before we need to convert the data into the matrix format. Okay, then let's try to convert this data into the NumPy format. Okay, so we want to convert, maybe if we want to just convert to only one data, one single data, and then this, let's say this is a temp data. Okay, and let's check the size of this data. Okay, this is just a single form, 1D array, right? And then I told you that first one is the first thing is just noting what kind the number of data, not the number, what can I say? The type of the class of the data. So let's say ignore the first data, and then you will get 784 values. So then you can convert this into NumPy. Okay, then we can convert this data. Temp data is now NumPy array. Then we may reshape this as 28 by 28. Then after this, temp data is shape of the temp data is 28 by 28. Then now we want to plot this data. We want to show the image. So this is not plot, sorry, plt.im show, image show. Then you will see the image shape of the data. So this data has this kind of shape. Okay, so it was handwritten data, and because the image is so small, when this is enlarged, and it looks like we can see the zigzags of each pixels. Okay, so if you can make it small, then you will see more clearly. Okay, this is the data, and there are many images. Like we can choose. This is number 0, and we can select the other data. Okay, the tens. Let's check what it was. Okay, it looks like this. Okay, what is this? Looks like number 2, right? But okay, and if we want to check the target value of this image, you may check the first thing, the first value, the first column of this. Then you see, okay, this is number 2. This was the number 2. Okay, then let's check. This is just we just checked only one data of the database. But what we have to do is we need to convert all the data into NumPy array, and then we want to train using the deep neural network. Okay, let's try. Okay, and what we have to do is first what we have to do first is we need to separate training data and target data, input data and target data. So this data, the variable data includes the input and target data both. So we want to separate them. Okay, so as you already know, we put the first column as Y. This is the target, and the other columns are put into the input. Okay, so this is what we are doing, and then another thing we have to do is we need to reshape of the matrix, because the original data was has the shape of the one-dimensional matrix, so we want to convert it into two-dimensional data. So this is what we are doing to change the shape of the matrix. Okay, then after that you can see the shape of this X train has been changed. Okay, you see there are 20,000 data, and the shape of the data is 28 by 28. Okay, then let's try to use this data and try to train the neural network. To train the neural network, we have to first develop and construct the network structure. Okay, so first we have to import all the libraries of Keras. Okay, then another thing we need to do is we need to change the dimension once again. Okay, now the shape of X train is just like this, 20,000 and 28, 28. But to use this data, to utilize this data for the neural networks, especially for convolution neural network, we have another dimension. So we are expanding the dimension, the last dimension. So after doing this, the shape of X train becomes like this, 20,000, 28 by 28 by 1. So last dimensional axis has almost no meaning, but this is just a requirement for the neural network. Okay, then the Y train value was first the number, decimal number, right? Like 1, 2, 3, 4, 5, 6 something. But after doing this, after applying this function, the Y train is one hot encoded. So do you remember the value of the first one? It was 6, right? Then it becomes like the 0, 0, 0, 0, 0, 0, 1, 0, 0, 0. So this means 6. The reason why we are converting the original decimal number into one hot encoding value is because of the network structure, and because we are doing categorical, we are using the categorical cross entropy to calculate the errors in the neural network. That is a pretty specific reason which you have to study neural networks to understand it clearly. So let's skip it here. Okay. Anyway, we are changing the decimal number into one hot encoding values. Okay. Then still finally we can develop neural network structure. So this is the neural network structure. This is not that deep neural network structure. This has the 1, 2, 3, 4, 5 layers and 2 convolutional layers and 1 max pooling and 1 flatten and 1 fully connected layers. Okay, then again, when we compile the network, then we get a model. If you type model and it just says, oh, this is a model. Okay, you can do, if you are really interested in the inside of the model, then you just type the function of a summary and you can get the brief structure of the neural network. Okay, then it's not that difficult. The amount of codes are not that much. If you want to train this network with the data, you already have the data, training data. You divide it into X train and Y train from the original data. Y train was the target and X train was the input. So you have the pair of input and output. We are training the epoch 10. So if the number of epoch is increased, then it trains more. Okay. Validation is to check the data, to check whether the training process is going well or not. Okay. This is validation split 0.3 is just a normal portion of validation, and you see the progress is going on, and as the epoch increases, you will see the accuracy is going to be increased as well. So it's when it was beginning, the accuracy was very low, but even when the first epoch has been finished, the accuracy was 93%, and it becomes higher and higher, and training accuracy is very, very high, 99% over, but the validation accuracy is still 97 point something. Okay, if you when it becomes epoch 9, 7, 9, 10, the validation accuracy is almost will be almost similar to this. Okay, and if the training process finishes, we need to test whether this training process has been done well or not. Okay, then let's just wait a few seconds to finish this. Right, it has been finished. Okay, final validation accuracy was 97.72%. Okay, then let's try to load with the test data. Okay, let's check how many data is there. Okay, we have 10,000 data, and the shape is still one-dimensional matrix. So we need to convert this training data as well, just like the training data. Okay, then we separate just like this. We see we also separated the input and output of test data, and we reshaped the data into three-dimensional. Okay, and when you check the shape, then you see it has been changed as you expected. Okay, then let's try to plot the data. Okay, the first data of the testing for the first testing data was has the shape of this. What's the number? Yeah, this is 7. Okay, this is pretty obvious. And then you will see y test 0. Yes, this is 7, right? So it is well matched. Okay, then let's try to check whether our model has been trained well or not using this data. Okay, then right, we need to convert this data into 4-dimensional. Okay, well, converted. Then we can test using the function of predict test. Okay, so now this predict function predict from all the test data, 10,000 data. But okay, so it becomes like this. Okay, this is pretty complicated. So let's just check for the first one. O, 0, and everything. Then you see this result. Okay, so this is this means the value of you can almost say it is not the possibility, but if to make the explanation easily, to make the explanation easy, let me just say this is the possibility of for each class of the data. Okay, so now that we are doing the data, this data. So this data, if this data is number 0, then the first value here is very high. If this is the number 1, if the machine recognizes this is number 1, then the value here is high, and this value denotes the degree of being number 2. Okay, this is number 3, 4, 5, 6, and 7, 8, 9, 10, and 9. And which is the biggest? Yeah, this one, number 7. So when you drew a bar graph, then you will see this more clearly. Okay, so when you drew the bar graph, as you see, all the other values here are almost 0. So there are no possibility of this image is 0 or 1 or 2, 3, 4, 5, 6. No, it's not possible, and it is 7 with very high possibility. Okay, so to this output means that this data is recognized as 7, the number 7. So we, after using the data of O, okay, all the data of O is looks like this. So we use the function of argument max. So then this is converted into the decimal number. Okay, then you see, okay, this is converted into the decimal number. So the first output was 0.00001 or something, but here is converted into 7. Okay, then let's just check if this value, this output is correct or not. Okay, so we can calculate the accuracy of this model. Okay, then we can compare output and the target value, and then we, after adding all the values of the correct number and divided by the number of all the targets, then we can get the accuracy. The accuracy here is 97.6%. So this accuracy was pretty high. And if you change your models here, all the things, as you see that this model is pretty simple, and we just trained this model with the 10 epochs. So if you train more epochs, and if you make the structure of neural network more precisely and make it better, if you can make it better, then you can get a lot better result. Not the 97, maybe you may get 99%. So try, if you are interested in this, then you can try to develop your own structure. But before trying to do that, you have to study the neural network structure first. Okay. Anyway, this was today's class, and just the purpose of today's class was to show how we can do the character recognition using the Python codes and in what we are doing in practice. So I wish you enjoyed this video. Thank you very much for your listening, and bye bye.